This is the scene of dismantling old large ships. Workers are systematically disassembling the ship's steel plates, which are then recycled by repair shops at low prices. In Pakistan, these discarded ship plates are highly valued by repair masters because of their versatility. They can be used for various purposes such as carriage saddles and excavator buckets, mainly due to their affordability. Today, a Pakistani master will demonstrate the entire process of making an excavator bucket using these ship steel plates. The retrieved steel plates will be classified by the master according to their different thicknesses and then cut into appropriate sizes using oxyacetylene cutting. You can see that the master is using a homemade semi-automatic cutting machine. The master only needs to mark lines on the steel plate, then switch on the machine, and it will smoothly cut the plate to the required size. After cutting, the steel plates undergo bending. To achieve precise bends, the master measures again before marking multiple bending points with chalk. During bending, multiple masters cooperate as the marked bending points guide them to adjust positions and bend sequentially. For more precise bending, the master has crafted an arc-shaped iron rod to compare the bends after each operation until the desired curvature of the bucket is achieved. To ensure seamless assembly, the master further grinds the steel plate surfaces to remove any excess burrs. Then, they start assembling the cutting-edge plate of the bucket. You can see that the master has chosen relatively thick material for the cutting-edge steel plate because the cutting edge is for an excavator bucket, which primarily comes into contact with soil and stones. The cutting edge must be sufficiently hard to protect the overall bucket structure to a certain extent, reducing wear on the bucket itself and extending its service life. The same applies to the side blades on both sides, which support the entire bucket structure. The strength of the side blades determines whether the bucket will deform. To ensure that the bucket remains in a parallel position, after welding the side blades in place, the master welds a tensioner in the middle as additional support. After precise measurements with a tape measure to confirm the correct positioning, the other side blade is securely welded. Once the assembly of the side blades is complete, the fabrication of the bushing for the bucket pin begins. Since it's custom-made, measurements are compared with another bucket. For greater precision, the master uses a piece of cardboard as a measurement tool based on the bushing template. After tracing the template onto the cardboard, the bushing seat can be accurately cut out. Despite using simple tools, the master utilizes them to their fullest potential. Soon, 2 bushing seats are completed, looking almost identical when placed together. However, the bushing is still in need of further processing, especially the inner ring of the bushing seat. Smooth surface must be achieved. This once again demonstrates the craftsmanship of the master mechanic. The master secures the bucket pin sleeve to the lathe. The lathe chuck is then placed on so that the bucket pin sleeve can be shaved by rotating the rod. Simple change of mindset. The lathe instantly becomes a milling machine. This operation probably has been practiced for 20 years. Even the experienced machinist has to give a thumbs up returning to the bucket assembly because the basic framework has been formed. The assembly of side plates is relatively simple. The addition of as long as the side plates and cutting edges are in a flat position, welding reinforcement is all that's needed. As for the excess steel plates extending out, the master only needs to cut along the edges and a bucket shape appears before our eyes. Start assembling the bucket pin sleeve seat. The bucket pin is the main component transmitting force and torque during excavation. To achieve force balance, the assembly position also needs precise measurement. Therefore, before assembly, the master will measure and mark the position with a ruler first. At this point, just align with the marked lines and weld the bucket pin sleeve seat for reinforcement. After welding the bucket pin seat, the master begins to assemble the bucket teeth because the cutting edge plate fits perfectly into the tooth seat. So here the master only needs to measure the spacing of each bucket tooth and then weld them for reinforcement for the bottom of the bucket. The master also doesn't skimp on materials and weld the pre-made steel plates in sequence. This greatly improves the wear resistance of the bucket. Thus, what seems very difficult but in reality, the production of an excavator bucket is not simple at all has been completed.